All right, sir. Let's dig on into this thing here. Now, this is another short and sweet kind of lesson. We'll breeze through it pretty quickly. As a network engineer, as a network support person, especially with so many people now that are beginning to work remote, and companies are finally beginning to realize that, for the most part, adults, if left to their own devices and and they're good at their job, they can be quite a bit more productive if they're not required to spend, hour and a half, 2 hours, sometimes 3 hours a day strapped to an automobile seat just to get into or out of work. That's not completely non-productive time there, especially those that have the long commute. So what we're going to take a look at here is the different types of access methods that people use to get into systems. I've mentioned several times before that in my humble opinion, if you want a secure connectivity environment in any kind of network that you're logging into, well, you need a VPN client of some sort. There's a whole host of VPN clients that are out there, very affordable, and you simply can't get a better protection on your connectivity, remote connectivity, than using a VPN. Okay. There's also several different methods that we utilize in order to connect remote to systems. Some of it is pretty much used by network engineers to log in remote and do support type of functionality. Okay. Now, wide area networks are those that typically have systems they're isolated inside of some type of a LAN, either a wireless LAN or a wired LAN connection. But those are more localized. They cover shorter distances. We see lots of wireless LANs because everybody's in close proximity to the wireless access point. And then we usually have collections of these local area networks, again, wired and wirelessly, that are joined together that constitute what we call a WAN, a wide area network. When we start getting into the large enterprise arena, multinational corporations and the like, those are very widespread, oftentimes across large geographical areas. But again, if you break it down to the smaller components, the department divisional areas, those are usually local area networks. Some of them are basic 802.3 wired local area networks. Some of them are 802.11 wireless LANs. But then all of those collectively make up this concept of a wide area network. More often than not, the WANs, the wide area networks, are utilizing the publicly available network, the internet, to actually give them the connectivity in and among all of the different locations there. There are certain components in a WAN or LANs and WANs that are associated with different areas of your OSI network model. The network layer there, that's your IP addresses, Internet Protocol, that's your routers, that is your customer edge and your provider edge equipment where they, connect at the demarcation point. That is your systems that perform the assignment of your IP addresses. Currently, of course, out over the public internet, we do an IP version 4. Lots of companies are already beginning to incorporate IPv6, but mostly inside their autonomous networks. Until we get the full global buy-in, especially with the manufacturers of the product, switches, routers, things like that, that are replaced out there that are truly capable of switching or routing 128-bit address, IPv6 address. We're sort of still stuck in the IPv4 world. There's a couple of technologies that are being employed there that do translation, 4 to 6, 6 to 4 kind of translation. But for the most part, those are not supported out over the World Wide Web, the internet. Okay. The data link layer, that's more simplified in essence. It uses typically switched type of connections, Ethernet type of connections. That is your switches, your MAC address oriented kinds of devices. And Ethernet, your 8-wire twisted pair Ethernet, and the Ethernet framework in general, is used now to do your hierarchical hardwired connectivity up to the demarc point to where the customer edge equipment, it talks to the provider edge equipment and gives you that launching pad onto the World Wide Web. Okay. There are in the WAN, the physical layer that we associate with the OSI network model. That's where your adapter is, your transceiver, radio transceiver, your network interface card, your modem, your physical cabling, your Ethernet copper cabling, either 8-wire twisted pair or a 4-wire pair, for instance, for your analog telephone calls, things like that, DSL modems, things like that. Those all are associated with and exist at the physical layer, and it's the same in your wide area networks. Now, a lot of different connectivity types that we see that actually form the initial connection to the internet. And remember, we had the discussion earlier in the week. All of the local telcos were basically grouped together because they were the ones that all already had the infrastructure either in the ground or hanging on telephone poles that provided the outreach to the public at large. And every little hill and dale, town, city, and village across the country, used to be. I remember when I was growing up as a kid, if you wanted to get telephone service, well, where's the telephone company? Oh, it's that block building down there on the corner of Main and Vine. And sure enough, it's still in most of your little smaller suburbs and towns, you can still identify that old concrete block building there, which now it's typically owned and staffed by your internet service providers. Okay. Because that's what the ISPs did. These large conglomerates of communication organizations bought up all of these local telcos and thus all of their local infrastructure components there, where all of the infrastructure terminated into that building, that block building that was the telephone company way back then. Now, as those things began to expand and grow and more diversification, then lots of, especially companies particularly, would they would lease direct connect communication lines between the company facility and the telco itself. Those were called T1 lines or lease lines, T1s, T3 lines. The speeds on those things were relatively slow, 1.5 megabits per second, and sometimes they would group together multiple lines, call them T3 lease lines. But it was a dedicated link between whatever company and whatever was their telco provider there. We also then started seeing DSL type of connectivity, and it utilized the existing analog telephone lines, the 4-wire telephone lines that were out and about in the hills and dales and villages. Relatively slow speed. There are 3 different flavors of DSL. There's your basic ADSL, they call it, asynchronous digital subscriber line. 24 megabits per second was the maximum download speed. And in those things, the ADSL, the upload speed was very slow, 6-7 megabits per second. Then there's a step-up version of that called SDLC, synchronous, or DSL, SDSL, synchronous digital subscriber line, and the connectivity upline downline was same, 24 megabits per second. And then we had the very high bit, call it VDSL, which the upload download speed also was very similar, not always identical, but very similar. And they promised on that 50 and sometimes up to 100 megabits per second. They never delivered that, but they promised it. Okay. And DSL was sort of the king of the hill, especially out in the, in the suburban areas about there. Then we started seeing the cable internet companies were coming in and dropping their coax cable. The coax cable was pretty good speed. And when they kept upgrading, of course, their network boxes, their modems, as it were, then the speed began to increase considerably there. The DOCSIS was the name, and still is in some cases, the operating system, and that's your digital operating system for basically for internet communications. That is still pretty much the standard on that are cable modems now. Now, a lot of those have been replaced as well with the fiber optic cable. Fiber optic comes right into the building, right into the back of the modem. That's what I have in both of my locations, fiber right into the premises I'm talking about. So, and in many, many neighborhoods and large urban areas now, we're beginning to see that finally now they've got the infrastructure in the ground. And in some cases, still hanging on telephone poles, not so much anymore, but infrastructure in the ground for delivering that high speed fiber connectivity right into the premises. Lots of organizations now have a sort of a hybrid mix. It's hybrid fiber coax. And some of them, the technologies, they call it fiber to the curb. And then some of them is fiber to the premises, right into the modem. And I have that in both of my locations here. The T1 lines they were capable, and the T1s and T3, the upgrade on that, they used a modulation frequency called time division multiplexing, where they would have different signals going down the same line, but they were frames that were serialized. This frame was this type protocol, this frame was this and this, so on. So the multiplex devices, the MUX demux systems they call them, they would package up all these different signals, send it down the line, and then the demux on the other end would disassemble those. And it's the same kind of thing as the cable internet, because on that singular pipe coming in, you would have in a standard home, you may have 3-4 different signal types. We have the same thing now with the fiber, a little bit different concept of the way it's distributed, but coming in on that singular old coax cable connection, people would have, for instance, all of their TV channels, and that would be, a couple of hundred, and sometimes even 1,000 individual channels of television broadcasts, audio and video kind of channels. They would have another couple of channels that were dedicated to their inbound and outbound internet signals, completely different frequency modulation there. Have another couple of channels that were dedicated to like home security systems, things like that. So all of those signals were multiplexed onto a singular incoming and outbound cable. So the different frequency modulation techniques and the different multiplexing kind of techniques were used in all three of these to deliver all of those very different types of signals to very different components inside the home, and then package them all together for the outbound signaling as well. Okay. Now, as I said, in most, especially metropolitan areas, we find now that the systems have been upgraded to fiber right, either fiber to the curb and then coax into the home, or even I've seen RJ45 connections into the home, or fiber to the curb and then coax, or copper to the home. But again, in a lot of places, well, that fiber runs right into the modem, right into the premises there, not just for residential, but for commercial businesses as well. The thing about the some of the older technologies, specifically your T1, T3 lease lines, DSL, and the cable modems, is that it was a shared component. The signal coming in on the primary cable, for instance, to a cul-de-sac, it went to a singular box, and then you had radiating cables that connected all the homes, and for instance, in the cul-de-sac or at the end of the street. And everybody was sharing that bandwidth. Now the great thing about the cables, the coax cable, was the distance on those things. I mean, pretty long runs there, 500 meters before you start getting any signal attenuation. But now with the fiber optics, we're talking about kilometers, 30, 40, 50, 60 kilometers before you start getting any signal attenuation at all. Okay. So fiber to the premise, fiber to the curb, different methods of delivering the information. And now, of course, we're seeing, especially commercial offerings, 2, 3, 4 gigabits per second. So very, very screaming fast speeds there. Fiber to the curb, the last leg of that is coax, copper cabling of some sort. But fiber to the premises, right into the modem, right into the commercial entity or the residence itself. And I'll tell you, the quality of the fiber cabling, the manufacturing process is unbelievable now. When the very first fiber that I ever interacted with decades ago, the fiber cabling, the manufacture process itself, you only had about a 30-degree bend radius before you fractured the cable. Boy, these new ones, 90 degrees almost. Blew me away when the technician was hooking it up here. They trenched it in the ground, came up the side of the wall, and almost 90 degrees went right through the wall and right into the modem. Blew me away. So the components, the materials that they're using now it's glass, plastic, composites, and even some transparent metals that they're putting in there to give it strength and to carry the signal very well. Some of the switching equipment now is still using the pure laser as far as sending the signal down the singular core. And some of the signals are using the very, very high intensity LED lights. And that's more for short run kind of thing, the multi-mode fiber there. All right, a quick true false here for you, sir. Customer and provider sites are linked via customer edge and provider edge routers with the assignment of public IPv4, IPv6 addresses. What do you think? True or false?
Well, it's mostly true, but it's also false because they don't give IPv6 addresses.
Well, you do get the IPv6 address. It's just not supported in some environments. You have to have the proper equipment in order to switch that address. So that's
Oh,
why, for
okay.
the most part, it's limited inside of the network perimeter, the autonomous network, because there's lots of switching and routing equipment out over the public internet that can't process that data.
Okay,
So
then
that
it's
would be
true.
considered true there. But I'm glad. I like the way you broke that down. Mostly true. Yeah. Yeah. If it were saying that, that I had the full capability out over the public internet for IPv6, that'd be absolutely false, no doubt. But yeah, it's true. The and I'll tell you that I think it's going to come down to, when we finally switched over from analog TV service to digital TV service, there was this large uproar. I always talk and make fun of my redneck relatives. I know I have a Southern accent, so people tend to think I'm quite redneck myself. I guess in some ways I are. I am. I are. But there was this public outcry because people were going to be required to get the digital receivers. And even when the government says, "Hey, don't worry about it, we'll give you the digital receivers for free," when they finally pulled the switch on that, switched over from analog to digital TV access, I could hear the constant wail of my relatives in South Georgia, Alabama, Tennessee, and areas there. Now, I talked about but I think that's what I was alluding to there. I believe it's going to take a worldwide community finally saying, okay, as of this date certain, if all of you network owners out there don't have your equipment upgraded to where it supports IPv6 all across the board, but then surprise, you're not going to be able to communicate over the World Wide Web anymore because it's not backward compatible. So it's all or nothing on the switch when it comes to that. Okay. Now, remote access methods, again, there are those that we use application software to accomplish. And then there are remote access methods that are baked right into the operating system of most of our systems here. Okay. The things we need to think about when we're setting up and starting to manage that remote access, in my opinion, at the very first top of that list should be security. Okay, I want to make certain that the connectivity between any remote clients and my system, my network systems, is tightly wrapped and very secure. Thus, two requirements, in my opinion: virtual private network and using encryption. Period. We find our data in the three states of being that we talked about earlier. The data is stored or at rest on some type of storage medium. Use encryption. The data is in transit between endpoints in a computer network. Use encryption. And now, of course, even I mentioned the term earlier in the week, homomorphic encryption gives me the illusion that I'm working real time on encrypted data, like if I'm editing a document of some sort. So the coprocessors and the very fast homomorphic encryption algorithms are being used there. It never exposes the information long enough in main memory for anybody to be able to actually steal it in the clear text format. The a couple of things that are requirements, as it were, as far as initially setting up and then long term managing remote access, is it has to come down from on high. You have to have very strict policies and procedures that management defines, with, of course, input from your security apparatus. You want to make certain that on a regular basis that you are reviewing your system logs, your remote connectivity logs. You want to make very sure that you're doing things at the bare minimum, like requiring multi-factor authentication. Okay? And you can even set up, and according to how, based on how secure your environment needs to be, I can even set up additional scrutiny layers. For instance, only allowing certain IP addresses or certain systems with a very particular MAC address to log into my systems. So the remote access front end systems, the gateway appliances, the login systems, the AAA compliant services we talked about earlier, requiring multi-factor authentication. Those are some of the things that I utilize to set up my remote access policies and procedures in general. At a very minimum for me would be a requirement of a virtual private network client, as well as using encryption algorithms. Okay. Now, in some cases, and we've seen this a lot, we see a lot in the DoD specifically. In the Department of Defense, every active member has a CAC, the Common Access Card. That CAC now is embedded with a digital certificate. So if they're logging into one of the network systems inside their secure networks, you've seen it, there's a slot on the device. You plug your CAC into that slot. And it validates not only you as the user, but also then validates that computer system to the network itself, utilizing that real-time exchange of public key, private key information. It also then wraps the data connectivity in a version of secure protocols called tunneling protocols. There's 3 or 4 or 5 of those that are available. And it encapsulates each and every data packet with sort of an additional or a third layer, if you will, which can conceptually be seen as the same way as in encryption algorithms are. Okay. So high scrutiny on each individual user profile, as well as the system profiles that are allowed to communicate with that particular network. Okay. And I can set up different types of protocol and software requirements at the hardware level and at the software level and at the network substation kind of level, the wireless access points, the wired access points, the switches. So multiple layers that I can apply different types of encapsulation or encryption there. Now, the tunneling protocols, these are the major ones that we deal with pretty much on a daily basis with secure remote network environments. Some of these are older, some have been upgraded quite a bit now. The new kid on the block is this IP security, IPsec. It's a network layer. It operates at the internet protocol is the concern there. Now, it also supports several of these other tunneling protocols. It supports multi-factor authentication. It supports encryption algorithms and different encryption algorithms on the connection there as well. There is another one called GRE, generic routing encapsulation. It's also a network layer function there. And it's widely accepted across the board in many different types of routers. For instance, GRE is a part of the firmware in most routers. Point-to-point protocol is a data link layer. That's more of a switch-oriented type of thing, and it's sort of it's not antiquated, but it is more of a legacy type of protocol, PPP, point-to-point protocol. There's several others. There's one called secure tunneling protocol. There is a couple of others. Let's see. There is your transport layer security, TLS. That's implemented as part of your secure sockets, your digital certificates. Used to be just digital certificate was SSL using, for instance, port 443 for your network connections, HTTP connections. Now it also puts that other layer, transport layer security there, which is yet another encapsulation wrapper around the data stream. Now, some of these, and you'll hear network engineers complain about it, do add a little bit of processing time on top of your clear text data transmission. It's nothing like it used to be, and I've told you a couple times already, don't buy into the excuses that they will throw at you for not using encryption, because there aren't really any reasons anymore. The technology advances, screaming network speeds, multi-core processors, all of those things. And again, you do have the latency. Don't get me wrong. It's there. There is a delay. But that delay now is measured in nano and picoseconds rather than seconds and milliseconds. So we just don't notice it anymore. And then now there is a initial setup that you have to go through and selecting the proper security protocols, the proper encryption algorithms. But the same thing with requiring a virtual private network client. That's an application layer kind of thing. And there are even now some websites that are written and they use in a newer version of the HTML coding process called HTML5 that allows you to generate from the server side a client-less VPN connection. So in the server code, it pushes down the VPN connection to the client, whether they have a VPN client installed or not, doesn't matter. So there are certain things that give me that multiple layer encapsulation there with using these tunneling protocols. Like I say, this guy is sort of the newest kid on the block. It's actually a twofold thing. You have the authentication header. The authentication header gives me integrity and confidentiality checks on the IP addressing themselves. Their IP address is there, and all the information that's encapsulated in the IP header. And then the second part of it is ESP, encapsulating security payload. That encrypts the actual data packet itself. So the two of those together gives me that end-to-end encryption of the entire IP frame, each and every IP frame. And along with, of course, the, you have your standard, it's got the from address, the to address, the error checking at the end of it, the cyclical redundancy code kind of checking there. IPsec also works quite well with VPNs. It also gives you that, in essence, it's like a triple layer of encapsulation wrapper around each and every data frame that is sent across the network. Okay. They use encryption algorithms for each and every data frame, IP packet that's sent. Some of them even use the key stretching and key salting kind of functionality, so that although each packet is encapsulated and encrypted, the encryption algorithm is utilized is just a little bit different for each packet. So if somebody is able to intercept one of those packets and basically brute force break what the key is, it's only good for that one frame, that one packet. So it's sort of like the same session level thing I was talking about earlier. The way that I set up and configure IPsec is pretty simple, as a matter of fact. It's multifaceted. You decide whatever mode your transport or TLS mode is going to be used for each data frame. You decide what the key structure or the authentication header part of it is going to be, and then the encapsulation algorithm is going to be used for the data frame itself. You can create and it's the same concept as a public key, private key for a digital certificate. You can create the key yourself manually, or you can have, as part of the IPsec configuration, have it where it will configure the key for each data frame, each packet, and manage it automatically if you wish. That'd be my preference. You then decide how the information is going to be sent, received, how the whole data frame and each frame and packet is going to be handled um, by either endpoints or a specific network host. So you set up the rule sets on that when you're configuring IPsec as well. And the thing about these configurations is you have to constantly test these things, run it in test scenarios. And I'll tell you, with hypervisors and virtual machines available, they make it so very simple to test this stuff and scrutinize the data frames and the packets and your configurations of it without actually going out over a public internet connectivity. And even in my sandbox type of environment, I can actually use the public internet and test my virtuals and my transmission of data out over that to assure that I've got IPsec configured properly. Now, one thing we have to do in IPsec is we have to exchange the keys, much the same way that I would exchange a key for a synchronous or a shared key type of encapsulation environment. Have to do the same thing here. Now, the Internet Key Exchange and the second version of that, IKE version 2, uses encryption with the key exchange too. So I have to have some secure means, some out of bound or out of band, they call it secure communication, in order to send the keys. Because in this type of environment, you have to use the same key to unencrypt that you use to encrypt the data. Shared key, symmetric encryption. Okay. So I have to determine, now in this case, we're talking about sharing it over an internet connection. So I have to make certain, and it also uses encryption algorithms to encrypt that exchange in a secure environment as well. Okay. Same thing with the key structure for VPN connectivity. I have to exchange the key in some secure mode. Here's what we do on Internet Key Exchange version 2. It uses that extensible authentication protocol 802.1 connectivity there, and that assures things like the protection of the IP address, the network address translation function that the router or the gateway device typically performs that. So as far as the end user is concerned, they don't have to do anything special, especially if you're automating the key exchange functionality and the protection of the key structures. So it all happens over HTTPS connectivity, Hypertext Transport Protocol Secure. It uses the tunneling protocols. There is a version of it that I can also use for mobile appliances, mobile phones, tablet, a phablet type device called Mobike, mobile internet key exchange, that kind of thing. And it encapsulates it all up in these encrypted packets and then exchanges that over the secure socket layers over internet connectivity to share the key. Now we don't see the we don't decompile the key or anything on our end, but the key structure comes, and that's the key that's used to unencrypt data after it is received. Okay. So same concept as a shared key where I would have to call somebody up and say, okay, the key for today is this, except that it uses internet connectivity to share that key structure as well. Okay. We have two different flavors and implementations of VPN connectivity, virtual private network client connectivity. One of them is called client to site, where I have an individual client running on my host computer of some sort. A lot of times that's your web browser. Sometimes, according to the connection type, you may have a very specific VPN client. Um, uh, for instance, the um, some connections in a Windows environment specifically, implementing virtual private network clients in Windows, you may have to install a VPN client. I've been playing around with one here lately. I mean, I'm not endorsing the product by any means, but I've had a lot of success with it. The latest version of the Express VPN. Some of the earlier versions that I wasn't particularly keen on, but this newer version I've been impressed with so far. And then there's another half dozen out there that are just as good there. So again, I'm not endorsing any particular product, but you need a VPN client on your system. Your VPN client is what typically will initiate the connectivity. It will basically send its beacon out and says, "Hey, do you recognize this VPN client?" And whatever server you're or host computer on the other end you're trying to talk to, it will send back basically a signal, yes, you are a recognized VPN client. Then they exchange the connectivity information. Okay. The client to site has your client talking with a VPN gateway appliance, they call it. And that sometimes is baked into the router device itself. So that's what actually negotiates the encryption algorithm and the tunneling protocols that's utilized before you exchange any information, and it secures that particular initial connectivity. And this is what we set up, for mobile workers, home-based workers. Then the other side of it is called site-to-site VPN, where you have VPN gateways on both ends of a connection, like between a home office and a branch office. And when those things actually fire up, and again, it's usually aggregated into the router gateway appliance. That's also the VPN gateway as well. And when those things start up, they pre-establish multiple pre-drilled tunnels, if you will. And look at it like drilling a little tiny diamond head drill bit tunnels through the granite wall that is the internet. Okay. So clients on either side of that, they just push data through those predefined and pre-existing tunnels there. Now, there's two different ways that I can set up, especially my client to site connectivity. There's one called the full tunnel access, to where everything that I do on my end or my client, including my internet browsing, is managed by the gateway device that I'm attached to. Okay, so if I want to browse the internet, I have to go through that corporate network access control there. But then there's another version called split tunnel. So my connectivity to the company assets, the company software, the company connectivity is through the VPN. But if I want to browse the internet, well, I do that on my side. So I have to control the security on that side, that split tunneling. Now, I still have the VPN, but that gives me the direct connectivity, not having to go through the corporate systems to, check my email or to get to the internet, things like that. Okay. So there are several different protocols. I mentioned the point-to-point tunneling protocol and the secure tunneling protocol. This guy here is older, the PPTP. It's been, unfortunately, a lot of folks still use it, but it has been deprecated. It is not used widely anymore. The ones that we see most often used now are the secure socket tunneling protocols and the layer 2 tunneling protocols. That's a one that is pretty commonly used by the IPsec implementation there. Very strong security, again, like having 3 encapsulated layers around your connection through that granite wall that is the internet. And I'll always use the example of, visualize the internet, the World Wide Web, which is the most unsecure environment you could ever imagine. Visualize that as a granite wall between your client computer and whatever server you're trying to attach to. When I fire up my VPN, I take the little smallest tiny 5-micron diamond-headed drill you can imagine and drill a tunnel through that granite wall. Well, that granite around all that, nobody can get to it. That's pretty good protection alone. Then I take one of these protocols, L2TP, tunneling protocols, the secure socket layer with the transport layer security, which then wraps the third layer, the encryption algorithm around that. So I was like literally like having three protection wrappers around my connection through that public internet, that granite wall, which is the public internet. Very secure. You just can't get any more secure than that triple wrap layered type of environment. Okay. There's the split tunnel I was talking about. The VPN connects to all of the enterprise network systems, but I control my own internet browsing, email browsing, unless I'm talking to an email server here, it doesn't matter. So it gives me dual control there. That's the split tunnel. And then the full tunnel is everything I'm doing, even my internet browsing, goes through the systems, the gateway systems inside of the corporate network. You see? So that's full tunnel. And one or the other of those modes is typically selected at connectivity time. Okay. So one or the other there. This is what I was telling you about the clientless VPN, the clientless virtual private network connectivity. HTML5, it uses very secure connections. They call them WebSockets, but it also uses a specific method of programming and particular HTML tags that are used to push out the connectivity of the virtual private network client. You don't have to have a virtual private network client installed on the workstations that are dialing into the server, whatever server it happens to be. Okay. Very low cost, cost effective. Hadn't got to worry about supporting a whole bunch of users out in the field that may or may not know how to configure their VPN. If you have like a company-based application server that your mobile crew is logging into, that's a great thing to look at. Great way to actually approach it right there. It is a little bit different concept of programming, and there's some additional tag parameters that you have to be aware of in the HTML5 programming kind of environment there. Okay. And again, the thing about it is, you hadn't got to worry about installing individual VPNs out in the field, or even worrying about supporting multiple varying manufacturers and providers of vendors of VPN products here. And sort of you push it out to the workstation itself. Apache Guacamole is one version of this that's used for either the VPN connection. It's open source, completely free application software, and then of course a lot of other vendors have their VPN connections there that clients that they make available. Again, I've been pretty impressed with two different flavors here. The Norton utilities, the Norton LifeLock has sort of joined forces there. They have a cloud-based VPN offering that's pretty impressive. And the Express VPN, I'm really liking that. I'm experimenting with that on both my wife's and one of my PCs here. But then there are other companies, Microsoft, Citrix, Cisco, whole bunch of organizations that have their different VPN clients. The site-to-site VPN is what I was talking about earlier. You have a VPN gateway device on both ends. Again, like a home office, branch office. It's very scalable. You can have multiple locations and all of them connected together in some type of round-robin connectivity. And you have virtual private network client connection that manages everything between the two sites. The gateway devices are what do it. Very highly secure. And it gives you at least the concept of a VPN that is always on. You don't have to, every time you want to communicate between those locations, you don't have to establish another VPN connection. It's already there. You just basically jump in and push data down the pre-drilled tunnels, if you will, between the locations. Okay, much less management. We don't have to manage each individual user's VPN because the gateway devices themselves actually do it. Okay. A lot of cases there where we would do that, in your Internet of things or your industrial implementation using a whole bunch of IoT types of appliances. Another area, say if your company is prone to go out and purchase other companies and integrate them into your existing network. More often than not, you have completely different technologies, completely different approach and mindset on setting up the network. So a site-to-site VPN is a pretty darn secure way to initially at least set up connectivity between the home company and whatever company's been purchased and is being integrated into their environment there. So a couple of different use case scenarios here that would apply for that site to site. But I tell you, any company that has multiple locations, home office, multiple branch offices, site to site VPN makes a lot of sense in my humble opinion. Okay. There it is. Like I say, the VPN gateway devices on both ends. And usually, even this situation here, you see here, it's an aggregated appliance. The router, the gateway, the firewall, it may even be the AV kind of system. Here they have them separated. Doesn't matter. It can be either or. But these guys, when they first start up, go ahead and pre-drill the multiple VPN channels or tunnels, as it were, that uses the public internet for that access. So very, very secure. And it's like having, dozens or even hundreds of pre-drilled, very secure, triple wrapped connections between the home office, branch office, and any other offices that they have out there. So site-to-site VPN. All right, sir. Another two truths and a lie here. What do you think? Internet Key Exchange version 1 is used for site-to-site and host-to-host VPNs. Site-to-site VPNs are ideal for home workers and field employees. Clientless VPNs allow users to access network resources via a web browser. Which one of those is the lie?
I'm just guessing site-to-site VPNs.
That's a pretty darn good guess there, sir. Yeah, site-to-site VPNs are not designed for home workers dialing in. That's client to site. Okay. Site to site connects to like a branch office, home office, that kind of thing. So well done. That's a pretty darn good guess there. And I'll tell you that guess, I want you to remember that when you start sitting for your certification exam. Trust your gut. Trust your gut. Don't talk yourself out of correct answers here. I have been guilty of that myself unfortunately in too many instances. And
That's one of
when
my
you're
biggest
taking
problems.
when you're taking the exam, um, they'll give the opportunity to flag the question for review, which is all well and good. But I go ahead and say, trust your gut and select the answer and then flag it for review if you want to come back to it and revisit later on. But don't come back and talk yourself out of a correct answer. Okay. I second guess myself a lot in those situations. So yeah, just be cautious with that and trust your gut, man. Especially you're taking this exam on Saturday tomorrow. So this information is real fresh on your mind. So trust your gut. I want you to wear those quizzes out tonight as part of your homework, and it should be even more fresh on your mind there as well.
Yeah,
Now
that's my
there are
plan as soon as I
several
get home from the
different.
doctor.
I'm sorry. Say again.
Said, yeah, that's my plan as soon as I get home from the doctor.
Very good, sir. Um, there are a lot of different access methods and technologies that are used for accessing remote hosts rather than the virtual private network client types of connections, those things. Baked into most of your operating systems, you have, well, the first protocol I ever used when I was working on the computer's merit badge way back in the dark ages was Telnet. Now, Telnet is not secure, never has been, never will be. So it is not a good remote connectivity alternative, especially if you're going to be connecting to systems that may be, security issues there. And in most cases, most of them are. Secure Shell is an alternative to that. The same as Telnet, it gives me that command line access to a remote system, but it does it using a secure socket. It's a port 22 is what you connect on secure shell. Now, the issue with that is that, excuse me, secure shell is not a native Windows protocol. So if we're going to use it in a Windows environment, you have to use some type of a secure client program. I use one called PuTTY, P-U-T-T-Y. Secure shell, it gives me that same command level access as Telnet does, but it is end-to-end security. And it dynamically generates key structures and exchanges them with the target system. So using a client like that, and there are several other secure shell clients too. But then we have things like remote desktop protocol for Windows. That's you are invited into a system and you take control of the desktop. So several different ways that we can use for accessing computer systems from afar, but we just want to make certain that we do it in a secure mode, not in clear text format. That's secure shell there. The benefit of it is everything end to end, or what some of the benefits, is encrypted, and it uses really strong encryption algorithms. Okay, the secure shell clients like PuTTY, and there's a couple of others, they dynamically generate the certificate, the key structures, if you will, and send that over the connection in secure format. During the transfer of all the data from your host machine to whatever other host machine, server machine you're talking to, all that data is encrypted and it's compressed. So it's very, very fast speeds. And Secure Shell has been around forever on Linux, Unix machines. It's supported also in Mac environments there. Once you establish a connection, there's a lot of different commands that we use there. SSH is the initial connection. This is your key generation, public key, private key for authentication. This copies the public secure shell key to the remote server. Okay. And then that is then authorized or validated on the server side. This adds the private key to whatever agent program you're using, the PuTTY program or whatever, so that those two exchange that information dynamically. And then the SCP command or SFTP command, either one, allows me to send and receive files over that secure shell type of connection. Okay. So these are the major secure shell commands you get. And we see this used a lot, as a matter of fact, as a secure FTP. I mentioned to you a couple of days ago, FTP by nature is not secure. Even if you're required to log into an FTP server with user ID, password, credentials, that doesn't automatically secure and encapsulate the file transfer. That's just to validate you that you can indeed use the server. See? So secure shell is the SFTP function that I talked about the other day. And then there's the other FTP secure, which uses a digital certificate the same way that this does. But this guy here, as my grandfather would say, you kill two birds with the same rock. You set up the secure shell connectivity end-to-end encapsulation, and then you use your secure FTP commands to transmit data. Here's old trusty Telnet. It is not secure, period. Okay. Runs on port 23 by default, and it is the good news is it's supported on just about every operating system on the planet. Okay, but it is not, never has been, never will be secure. It gives me that terminal emulator command shell kind of functionality, but it's all clear text. Okay, so I don't want to be
port 23 by default.
Yeah, it's port 23. Yeah.
Yeah, close it by default.
Say again?
Close it by default.
Yeah, yeah, yeah. Yeah, I don't want to use, like I say, the very first command I ever issued when I first got my hands on a terminal was Telnet. I thought it was the coolest thing in the world that I could actually run, commands and programs on a target system there. Now, we see Telnet oftentimes used by network engineers to log in and take control of their switches and their routers and so on, which is all well and good, but it's not secure. So There's other means of communicating with those things in a much more secure environment. Me personally, I use a virtual private network client. Remote desktop protocol baked into your Microsoft operating system environment, runs on port 3389. It uses a client server kind of connectivity, but you, like a target user, a remote user has to basically invite you into their systems. And then when you connect to those systems, yeah, and you have to live within the network authentication mode. You have to have network credentials to log into that system, and then you basically take control of it. It's like it displays their desktop in your panel. And the new RDP clients I've seen also have the chat box that where you can do interactive chat real time with them. So it's, you truly drive that system just as same as if you were sitting there in front of their computer running their keyboard. You got full control of it. It does have, it's called Remote Credential Guard, the RDPRA, where, for instance, if I am going to log into that system and have administrative privileges, well, I have to know what the administrator password is on that system. Okay. So again, it's just as if I am locally attached to that machine once I begin to see their desktop in my panel there. Okay. Um, any workstations that I want to use this thing on, I would certainly recommend either the virtual private network client. I want to be very, very careful in running and or allowing access to these systems and allowing that full administrative access. Because I mean that's keys to the kingdom there. You got, if you got administrative access to that workstation, oftentimes that administrative access also gives you a jumping off point or a launching pad into other connected or tertiary systems there as well. Okay. Now there's some alternatives. I'm a big fan of TeamViewer. I've used it for years. My older brother is, shall we say, not technically inclined, so I oftentimes dial up and as the way he calls it, fix what he unfixed. So I use that as opposed to RDP. It's secure. I can set up in a secure mode. And then there's other alternatives as well. There's virtual network client or virtual network computing. It's a client server kind of thing that we see set up for like in Linux and Unix type of environments. And then Citrix has remote access products in that they have available, and it's pretty much for any kind of operating system environment that you can run out there. The out of band management (OOB) is something we have to worry about here as well. I've mentioned a couple of times this week already setting up the extranet, the demilitarized zone. One of the things that I've done in those environments is set up, excuse me, these servers called jump servers. And the jump servers were defined to allow me to manage functions inside the largely the building that even though it was part of the company network, it isolated me in that area, that in that DMZ, or isolated whomever the support mechanism or the personnel were. I've set them up that give me administrative functionality to building automation systems, administrative functionality to the environmental control systems, the fire suppression systems. We set one up, and it was a company that managed the parking garage, multi-deck parking garage that was associated with this building. Completely different, separate management organization there, management and security organization, matter of fact. But all of those systems were tied into the corporate network, but were isolated. The access and the management control were isolated inside this DMZ. So that was out of band kind of management functionality there. Okay. Now, in some of those systems, in order to be able to facilitate management for like the fire suppression systems or the environmental control systems of the building, the primary access into those systems was the corporate network entry point. But let's say for whatever reason their corporate network entry point was down. Well, we would maintain these auxiliary, sometimes even dial-up auxiliary connections into just that portion of their network, so that if the internet were down, the landline may not be, and I was able to actually dial in and manage and control those things. Okay? So it separates that connectivity completely from the rest of the data traffic that may be attempting to get into the rest of the network. Okay? So, but they have to be configured very carefully and to give you that out of band management. There's the jump boxes I was talking about. You connect only to the jump box, and the jump box is only connected to other very specific systems. The connectivity to the jump boxes also, we had basically three primary connections there. We had the access directly to the servers from the public internet, which hit the router. It says, yep, you're validated for the DMZ, but you can't get further into the corporate network. We also, we maintained that remote desktop, well, TeamViewer is what we use, but same kind of concept as the RDP connectivity into those, secure shell connectivity. And then we had the out-of-band dial-up auxiliary connection to those systems as well. So we had redundancy there on what we could and could not get to. Okay? But this gives me that jump server kind of management capability, albeit in an isolated or a screen subnet area of the network. Here's a pretty good example of the jump servers in the extranet, or the DMZ, as it were. Internet access, or dial-up access, or the out-of-band kind of access. When we go in initially to the network connection from the outside world, this router says, do you have access to this DMZ? Yes, you do, so it allows me in there. If it says, nope, you don't have access to the DMZ, then I'm routed to the inward facing for the rest of the network system, okay? And then it allows me the enterprise network activity. I don't get to access the jump servers there. So pretty good isolation of those very specific types of systems. Okay? Now, you're going to hear the terminology quite a bit here, the automation and orchestration. There is a whole protocol set that's called SOAP, and it's more from a security aspect. It's a security orchestration, automation, and response. Is what that acronym is. There are many different, and these are typically connections between different components inside of the same network. And they all provide some type of API, application programming interface, between individual systems, individual components within those systems. Now, I mentioned to you at the beginning of the week, and I'll say again, the importance of learning a scripting language. My preference is Python, but there's other scripting languages out there. There's, of course, JavaScript, there's PHP, there's your shell scripts, bash shell scripts for the Linux and Unix areas. Whatever scripting language that you feel comfortable with, learn it and use it for automation. The automation concept works in so many good, valuable ways. I've talked a couple of times about old dyslexic Donnie. Well, if I put automation functionality in scripts, it sort of removes the possibility that I'm going to key something and mess it up. Okay. It goes a long way as far as taking out the human possibility of making human-oriented types of manual mistakes there. Okay. So learn your scripting languages. It allows you to automate a whole bunch of processes and procedures, but it also allows me to orchestrate the handoff of data between disparate systems, i.e. the APIs. The APIs have very specific requirements on the way that messages need to be presented and formatted. Well, if I script that and do it automatically, that is a real clear-cut orchestration kind of function there. Okay. Different APIs for different types of systems, making certain that I hand off data from one application to another application, one system to another system, that I hand off that data in a secure mode is of utmost importance, no doubt about it. Remember, I told you a couple of times throughout this week, too, this importance of this concept of principle of least privilege. Okay. if you use that as a base starting point, then you have an excellent framework to build a very secure environment on top of. Remember, and this doesn't just apply to people, persons, services need only have the minimum level of access required to perform the job function. Okay. Remember that and keep that as a base level principle of least privilege. And that is a good, solid framework for building a very, very secure environment. Okay. All right, let's ask some more questions here. All right, get ready to name that command, sir. Connects to a remote server to initiate a secure shell session. Gave you the answer in the question. What do we call that?
SSH.
SSH, secure shell command, no doubt about it. And then once we establish a secure shell connection, or even a team viewer or RDP, or not RDP, but team viewer connection, we can use this command to securely copy a file between hosts on a network.
You can use either SCP or SFTP.
Well, it's SFTP, or the one they were looking for here with the specific secure shell command was SCP. Yeah, secure copy, SCP. And then finally, this secure shell command adds a private key identities to the authentication agent. What is that secure shell command?
Shit.
And I'll give you a hint. All this, most of the, well, not all, but most of the secure shell commands begin with SSH and then a dash, and then they give you the answer in the question. Adds a private key identities to the authentication agent. What would that be?
SSH-PKI.
SSH-add. Add. Yeah. All right, sir. Very, very well done. The time is nigh. Now, to summarizing that, we looked at your local area network, wide area network, wireless LAN connectivity. We looked at the options that we utilize to interact with those things, the connectivity, the remote connectivity. We talked about virtual private network clients. We talked about multiple ways of connecting remotely to a system. Remote desktop protocol, RDP, secure shell protocol, the secure FTP. And I also, sort of reiterated at the end of that, the importance of learning a scripting language so that you can automate functionality